These are the centers where we developed the copper 64 ideas. We produce copper using a solid target station, an industrial solid target station from IBA system. That is probably the only one in Europe to have this production. We produce 2 curie of copper in each run. This is the new target system. We have a market authorization in Europe as cuprimina to use copper as precursor. And now we ask the variation to use for direct injectable use. Copper 64 introduced a lot of innovation inside Theranostic. The first innovation is the target. The target is DNA. It's the first isotopes in the history of nuclear medicine that have direct link with the DNA. We heard a lot about PSMA, but PSMA is, in any case, a membrane target. How is this mechanism? It's another innovation of copper is a physiological pathway to arrive inside DNA. Copper goes inside cell using CTR1 transporter, and there is another transporter very interesting that is ATOX1 that brings copper inside the nucleus. This is the mechanism how the CTR1 brings the copper inside the nucleus. There is a crucial point, very important, that after, in our experiment, in prostate tumor cells, after 1 hour, we found 40% of copper inside the nucleus. This is a crucial point because it opened the new possibility for theranostic approach. In normal cell, the copper remains on the cytoplasm. This is very important because one side we have a specific link with the copper inside DNA, and the normal side remains in the cytoplasm. This explains also the low toxicity of the compounds, because Auger fat inside the cytoplasm have 0 possibility. This is another great innovation that copper go inside the nuclear medicine and theranostic medicine. Auger fat is a jump out of electrons outside the orbital. The electron decelerate inside the SNA for Bremsstrahlung effect. This deceleration produces electronic wave. It is electronic wave under the mathematical model of Einstein theory that produce an alteration of electronic wave of DNA. This is a crucial point because it's the first time we use quantum physics. Until now, we are using isotopes like yttrium, lutetium, uranium that use linear physics. This is a completely new approach. It became a real theranostic approach because we go inside the electromagnetic circuits of DNA, where there is the memory of DNA. In other sense, we introduce an antimaterial treatment. It's the first sample in nuclear medicine theranostic procedure. There are some papers that describe the damage on DNA that can produce copper. And there is also a DNA repairing system. And we are using, in some cases, a fractionated dosing in the time that DNA repair. In terms of distribution, it's very important. The liver is critical organ, but it's very important that there is very low excretion in prostate cancer, prostate area. This is very important because it's another crucial point in terms of theranostic. This uptake of the liver helps the tumor uptake because the liver realizes a biological catalyzer because it put copper in the circulation because it relink copper with peptides. We do an interesting, we are closing a phase 2 trial in Italy, but inside these phase trials arises a thing very interesting, especially in patients with low PSA. We observed 37 patients with low PSA, lower than 1.1. In all patients, after 1 month, we observed a reduction in PSA. This is very important because this observation kept open another new revolutionary idea inside Theranostic, that when you do diagnosis, do treatment, without changing anything. When is possible? It's possible for two reasons. The first reason is you use quantum physics. Using quantum physics, there is no linear correlation between dose and effect. The second thing is you are very small lesion. We observe the lesion about 2-3 millimeters. It's very important to define for theranostic medicine what is the role inside clinical practice. Because I think that I observed today and yesterday a lot of paper the analysis in metastatic phase. But we are sure that this is the role of theranostic. Or not is the early phase, early treatment. This is the window probably that can change the role of theranostic medicine. This is an interesting comparison between copper and choline in normal biodistribution. You can observe the area of a prostate, completely clean, and in the other side with choline, we have bladder. And we have the same using copper PSMA, using gallium PSMA, probably. And this is another thing that we are using choline. We observe this uptake, the medullary system, that is absent in copper. In other sense, the picture of the area that you would like to study is completely clean. There is a paper, the first paper, first human use, that is a paper right from an Italian group, a mixed group, Italian-Austrian group, that describe also the dosimetry of the tracer. And I can show you some clinical case. This is a 69-year-old prostatectomy patient with a PSA 0.6. It is a local relapse that is visible using copper, is not visible using choline. We also have histology confirmation of these cases. Another case, if you can see, we have the same problem. We have local relapse, and this is the MRI, PET MRI fusion. It's very good visible lesion. This is another case of a lymph node relapse. If you observe the difference between copper and choline, we observe a more the details of lymph node, and especially we have some lymph node that was negative using choline. This is the detection of a very small lesion. This is the point of a passage between this application and the other. This is a lesion about 2 millimeters with the PSA lower than 0.406. These are other cases that show whether it's possible to observe the relapse in the inside lymph nodes that was negative with the choline. The fact that there is an important fact in terms of physical characteristics between copper and gallium 68, the positron range. Gallium has a positron range of 4 millimeters, copper has a positron range of 1 millimeter. That means that gallium probably do not have the resolution to observe the early phase. This is very important. There is a nice paper that describes how it's not possible to have a small detection of a lymph node using gallium in comparison to copper 64. If we do a game mixing some crucial points inside in terms of theranostic, that could be nucleus uptake, urinary excretion, positron range in terms of resolution. We're comparing different compounds. If you observe nuclear uptake, we do not have using choline, gallium PSMA. Using copper PSMA, we have reduction. This is a problem that we introduce using PSMA. We have a reduction in the uptake inside DNA. And this is a big problem in terms of theranostic application, because one side we think that the PSMA is more specific, but limit the theranostic possibility. And urinary excretion is low only for copper chloride. Positron range, this is the resolution. Combining this characteristic, we have the best score for copper alone. The future, we are studying the possibility to arrive to a personal theranostic dose. We studied inside an experiment said that the killer dose is the minimum 1 becquerel 1 cell. Minimum because we are inside the quantum-physics field. We are not a linear correlation. It is important to define the minimum. After this calculation, we can translate in PET this mathematical model, the exact doses. We have started now to do this calibration directly in the patient cells after biopsy, before decide how to treat this patient, to arrive directly to a personal dose inside the cells of the patient. And this is open a new era of real fusion, as in the sun. This morning I heard something about Big Bang. And probably I hope that copper is the Big Bang of theranostic medicine. Thanks.
Thanks, Valentini. Any questions to? What about liver metastasis? Just like Colleen, you're going to have problems with liver, visualization of liver.
Sorry?
Liver metastasis.
Liver, yes. For copper, for prostate cancer is a rare case. But in late after 12 hours, it's possible to see metastatic lesion in the liver using copper.
Do you have any comparative data compared to the gallium-60H HBED PSMA-11?
No, we didn't do comparing data in terms of clinical trials. We have also occasionally data that the problem is theoretically gallium do not have the resolution to see.
Yeah, I mean it's very theoretical because centres like ours or others that have both experience with perhaps carbon-11 choline or fluorocholine and gallium PSMA, we know that the target to background with gallium PSMA is sometimes 5 to 20-fold higher with the PSMA ligands, and we see structures that are as small as 2 millimeters with really very high SUVs. So the theoretical limits of the 4 millimeter positron path length doesn't seem to be a clinical problem. It's more a theoretical problem.
The problem is to define the target of a theranostic approach. What is the target? Is membrane or not? Or is DNA? The problem is this. This is the difference of because if we think it is DNA, PSMA is introduce disadvantages, not advantages.